Hi, Sheena. So what I'm going to do is kind of show you what is in table number 14.4 on pages 474 to 475, because that will help you answer question number 6. Now, question number 6 has two levels of the A factor, which means two rows. It has three levels of the B factor, three columns. And in the examples, we have 2 by 2 rather than a 2 by 3. So I've set it up with the values in the 14.4 table, part A, to show you what a main effect for factor A and no effect for factor B and no interaction would look like. And the way you tell is you take a look at the mean. So we've got in A1, B1 is 20, A1, B2 is 20, and A2, B1 is 10, and A2, B2 is 10. And when you look at the means, they're 10 points apart. The top row, A1 row, has 10 points more than A2. So there's a main effect for A. There's a difference there. And the difference can, when you use a statistic on it, you'll be measuring the magnitude of that distance and seeing whether or not it's far enough apart to be significant. In B1 and B2, however, when you look at the means, they are identical. And because they're identical, that means that there's no main effect for B. Basically, column B1 has the same mean as column B2, so there's no main effect there. When you take a look at the chart, which is taking these values and charting them out, and you can do that on paper, it's not that difficult. I did them with the charting section for Excel. You can see that these two lines are parallel. They have the same kind of pattern going on in terms of the values in each of the cells, and they're flat. They're identically parallel. Whenever you see two lines that are parallel or somewhat parallel, again the F statistic will let you know whether or not there's enough of a parallel going on that it's significantly nothing, essentially. When you see something that's sort of parallel to absolutely parallel, there's no interaction there. Everything is kind of happening the same when you go along. Now, if you go to 14.4 to B, and we put those values in, you can see that things are happening in that chart. And now, again, you take a look at your means. And this time, the mean in there's a difference between the means of the two levels of A. There's 10 points there. And then there's 20 points between the means of the two columns. That's the two levels of B. So there's main effects for both A and B because there are differences there. And again, the ANOVA F value, the F ratio, would tell you whether or not that's big enough to be significant. But you can see that there's that change. And you can see that in the chart as well, that both the level of A, the row stuff, that's this blue guy here, there's a difference between the first part of that factor and the second part. And there's an even bigger difference for the B factor. B1 is a lot smaller than B2 is in terms of the relationship to how much the deviation is, or the slant of that line is from A. So there's main effects for both of these, but they're still kind of parallel. They're not that far off from each other. You need to have something that's non-parallel in order to get an interaction. So now I'm going to show you C, and this A1, B1 is the same. A1, B2 is 20, and A2B1 is 20 and A2B2 is 10. Now, right away you see you've got an opposite kind of a pattern in here. The lowest value in the B1 lane is in the A1B1 slot, and the lowest value in the A2 lane is in the A2B2 slot, and the opposite is happening. The two higher values are in the opposite area. So right away you know those two lines are not going to look at all alike, even though the means are the same, which means there's no mean effect for the two levels of A, and there's no mean effect for the two levels of B. There is this pattern in terms of the values of the data, and when it gets charted, you see that we have one flat line for the B factor, which is the columns, and we have a tilting line for the A. So there's non-parallelism going on here, and it's pretty pronounced. That means there's an action. There's an interaction. So in this particular example, in 14.4c, you've got no main effects in terms of either one of the factors. The rows are the same in terms of the means, the columns are the same in terms of the means. But because of the different positions of those values, you do have a non-parallel situation there, and that means you have an interaction. So to solve 6, you're just going to take, you set up your, they give you everything but the A2B3 cell. So you just want to fiddle with that a little bit and see what kind of a value you need to have there in order to, let me go see what it asks again, in order to have a no main effect for factor A. What kind of value would you want to put in this B3 A2 slot, because it gives you A1 B3. And then in the second part of that question, they're asking you what kind of value would you have to have in that spot for there to be no interaction, for there to be parallel lines in your chart, parallel values, a similar type of a similar type of a difference between the columns and the rows. So you just kind of mess with it until you come up with something that works, and that's your answer. Now, when you go to the next question that you were worried about, which is 8, where you want to go in the, let me put for this is, it's page 498 at the top, gives you the DF formulas. So when it's asking you about what is the DF going to be for, well, how many levels of factor A are there, how many levels are factor B, and what would the DF values be for the interaction. And it gives you your information that you need to kind of figure that out. It gives you the F ratio for factor A, the F ratio for factor B, and the F, and then from there you can figure out what it would be for the interaction. And on the top of page 498, that's where you have those 3 formulas that tell you how to calculate the degrees of freedom for level A, and the degrees of freedom for level B, and the degrees of freedom for the interaction. So you should be fine there. So I hope that helps, and I'll drop you an email when I get it up on the on YouTube. Bye now.